Well, good morning, Tony. So far, you're the only one, so I guess you're going to have a one-on-one lesson for today. Monday, December the 7th, we're continuing with the review of Chapter 4. All right, Chapter 4 is about probability. We're going to look at this question 21. If events B and C are independent, that's important, which of the following is not true? The probability of C, given that B has happened, equals the probability of C. Second one, the probability of B and C equals the probability of C times the probability of B. 3, the probability of B, given that C has happened, equals the probability of C. Or 4, the probability of B or C is equal to the probability of B plus the probability of C minus the probability of B times the probability of C. So, can you just indicate which one you think is not true? Okay, C is not true. And why do you say that? You can either use the microphone or you can use chat. You think it should be the probability of B given C equals the probability of B. Is that one there? I don't see that. Oh, you're changing it. Don't change it. Just tell me why you think that C is not correct. Do you know which one is not correct, Tony? Because C is not correct. Sorry, is true. I apologize. It is true. Okay, they're independent, but remember what the slash means. It means, for this example, the probability of B happening, given that C has happened, is equal to the probability that C happens. Do you see how that is true? C is happening first, so this is correct. The probability of B, given that C has happened, is equal to the probability of C happening. Do you understand that? Do you understand the logic there? So yes, C is true. However, the one that is not true is A. So look at the logic. The probability of C happening, given that B has happened, is equal to the probability of C happening. Okay? Remember, this is conditional. This is a conditional probability. So if B has not happened, how can C happen? Right? Because B must happen before C happens. Do you see that? Okay. I know probability can be confusing sometimes, but try to figure out the logic if you get a probability question. Yes, okay. You are configuring a new computer from an online manufacturer and can choose from 4 different processors, 5 hard drives, 4 RAM options, which is random access memory, that's memory for the computer, and 2 graphics cards. You could configure exactly 15 different computers. Is that true or false? Yep, think about it. Just figure out how many combinations you can have there. Have you thought about it? If you're not sure, tell me. Okay. So how 15 came about was they added 4 plus 5 is 9, plus 4 is 13, plus 2 is 15. Okay. Do you think that is the proper way of figuring how many different computers you can configure? Okay, you don't think so. Why? Look at the first one. You have 4 different processors, right? So already it's 4 different times. What you have to do is multiply, what I'll show you. This is how many you configure. It's 4 times 5 times 4 times 2 equals 160 different computers. You multiply instead of adding, okay? When you want to find the maximum number of combinations. Does that make sense to you? Okay, because if you remember in some of the videos, they're talking about probability. So if you write down every single probability, which I don't want you to do, you can start figuring out it is going to be more than 15 different computers. Okay, so by multiplying them, you're going to get the maximum number of different computer configurations. All right, is that clear? Okay, great. All right, so a group of 8 friends has assembled to play basketball against a rival team. If all 8 friends can play any position, there are 6,720 different 5-person basketball teams that could be formed. Is this true or false? So what do you think? False. That is correct. Okay? Because you know there are 5 different positions on a basketball team. There's only 5 people when you're playing basketball. And then you configure each combination. Okay? So what would it be here? 8 times 5. So you can have 40 different, right, 40 different basketball configurations, not 6,720. It's just like the previous question. Okay. A decision tree is one way to represent a sample space. True or false? Oh, yes, I guess we're clapping for you. Okay, true, that is correct. Very good. So a sample space is a collection of all possible events which can be organized into a decision tree. Very good. All right, question 24. Let E be the event that you roll an even number on a toss of a single die. That's one die, not dice. So which of the following is not true? The probability of E equals the probability of E quotation equals, sorry, that should just, I don't think that should be there, equals 0.5. Oh, see, they're separated. So E prime, that's what it's usually called, is equal to 1, 3, or 5. The probability of E and of E prime equals 1. The probability of E or E prime equals 1. So you tell me which one you think it is. Just hold on a second. Oop. Okay. Sorry. That is correct. You are correct. Okay. So you know that the probabilities always add up to 1. Exactly. The chances are equal. Okay. Very good. Okay. Bayes' theorem is used in which of the following situations? When new information can be used to revise previously determined probabilities, when multiple events are mutually exclusive, C, when multiple events are independent, or D, when new information can be used to eliminate an event from consideration. So think about that one. Okay, you think it is A, and why do you think it's A? You have a reason? You have any reason? You're not sure? Okay, you are actually correct. All right, so when new information can be used to revise previously determined probabilities. Okay, so Bayes' theorem is an extension of conditional probability. So if, then, that is used to revise probabilities on the basis of new information. So you use the theorem when you get new information about the probabilities. Very good. Next question. If. No, it's not. It's revision, not elimination. So if the probability of X equals 0.5 and the probability of Y equals 0.3, and the two events are statistically independent, then the probability of Y given X equals the probability of Y. Is this true or false? All right. So is this true or false? True. And why do you say it's true? It's telling you in the question. Yeah, just like exactly. But it's telling you the two events are statistically independent. Right. Okay. Very good. So when X and Y are independent, the outcome of a Y given X will not depend on X. Hence, the probability of Y given that X has happened is equal to probability of Y. Right? They're two independent, so they can happen regardless of if the other one happens or not. Very good. All right, so Bayes' theorem is an extension of the conditional probability concept. True or false? Okay, sorry. True. And why do you say that's true? You know why it's true, Tony? Yes, exactly. It's like the previous question that we had, right? So it is an extension of the conditional probability. You're revising it now. So Bayes' theorem is used to calculate a revised conditional probability, like we saw in the previous question. All right. Abigail, Brenda, and Charlie take orders at a fast food restaurant. Abigail processes 35% of the orders. Brenda takes 25%, and Charlie does the remainder. Okay, so what percentage does Charlie do? You should know that already from this sentence. Abigail processes, right, okay. That's what you got to do when you're reading the questions. It doesn't give it to you, but you can figure it out because you've got 35 plus 25, and 1 minus 6.6 is 0.4 is 40%. Each of the employees will make an occasional error when entering orders into the terminal. Abigail has a 2% error. Brenda makes 0.5% of error, and Charlie's error rate is 1%. Given that a mistake was made on the order, the manager wants to know the probability that Charlie was the one who entered the order. Which of the following concepts will not be used in the analysis? Events that are mutually exclusive, events that are collectively exhaustive, events that are statistically independent, or Bayes' theorem. So you figure out which one will not be used in the analysis. What you can do is see, do these meet all the conditions of what the question is asking? Do you think it's C, events that are statistically independent will not be used? Okay. And why do you think these events are statistically independent? What makes you think that they are statistically independent from what you're given, what information that you're given there? They're taking orders, yeah. All right. Does that mean they're statistically independent? Not independent. Okay. So that means it's not C because they are looking at them in terms of the orders. The orders are the common variable there. So if it's not C, yeah, which one won't you use? Okay. Statistically, they're independent, but collectively, they're dependent. You got to look at the language. Okay. That's the important thing. So if it's not C, which one would it be? B, events are collectively exhaustive. No, they are collectively exhaustive. Okay. You're reaching the limit. That's the max. What did we look at previously? What element? What element did we look at before? Okay, we looked at Bayes' theorem, right? Because it's used to revise conditional probability. You don't have to revise the conditions have not changed, right? They're the same. So the answer is D, Bayes' theorem. It's used to calculate a revised conditional probability. You're not changing that. All right. So is that understandable? Do you understand that? Okay, great. All right. A Venn diagram can be used as a basis for calculating probabilities associated with the union, intersection, and conditional probability statements associated with two or more events. Is this true or false? Oh, are you saying true? You've got two yeses on your chat. No? Is it true or is it false? Oh, you're still thinking. Okay. Should be true. Okay. And why is that? Well, it tells you, a Venn diagram can be used as a basis for calculating probabilities. Right. Okay. The answer is true. You are correct. So Venn diagrams can be used to represent a sample space from which probabilities can be determined. Right? Because the Venn diagrams represent the whole sample space. So it's got everything in that. Okay, so we finished chapter 4. Are there any questions about it? And of course, you can go through this again if you want and look at the PowerPoints for the chapter as well as looking at the questions. Okay, so I will put in chapter 5. And I'm not sure why it's not going. Okay. So chapter 5 is Introduction to Discrete Probability Distributions. All right. So if we look at there's question, what value is the sum of the probabilities in a binomial distribution? A, it varies with the number of terms. Oh, you're already saying C. And why do you say C? What's the reason you're saying C? Tony? Exactly. Exactly. They should always be 100% or 1. Very good. Because all possible outcomes for a random variable form a mutually exclusive set, the sum of the probabilities associated with the outcomes must be 1 or 100%. Very good. All right. A particular game of chance has 3 possible outcomes: win, lose, and draw, with associated probabilities and monetary payouts given in the following table. You have X, which you lose. The probability of X is 0.4. You're even. The probability is 0.45. Or you win, and the probability is 0.15. When you have a table like this, always make sure it adds up to 1. Okay? Your probabilities, as mentioned in the first question, should all add up to 1. So what is the question is, what is the expected value of the monetary winnings loss from playing the game? A, $25. Okay, you're already saying it's you lose $5. Is that it? Okay. Very good. That is correct. Excellent. So the expected value is the sum of the products of each outcome times the probability associated with the outcome. So minus 50 times 0.04 plus 0 times 0.45 plus 100 times 0.15 equals minus $5. Very good. Excellent. Excellent, Tony. Okay. So, again, the same game. A particular game of chance has 3 possible outcomes: win, lose, and draw, with associated probabilities and monetary payouts given in the following table. It's exactly the same as previous. And now I can't remember what the question was. Okay. So let's forget that question. I'm not sure. I can't remember what. Yeah. No question on it. Don't worry about it. My error. All right. A binomial distribution has exactly how many possible outcomes? 6. B, it depends on the problem. 1 or 2. 2. And why is that? It's binomial, exactly. Okay, very good. Very good. Binomial distribution has 2 outcomes, one called a success and the other called a failure. Very good. I don't know. Some people get confused, but it's binomial. It's already telling you what kind of distribution it is. So the hypergeometric distribution uses sampling with replacement. Is this true or false? I assume you're thinking about that. Do you think it's true? Why do you think it's true? Oh, sorry. Oh no. What do you mean, oh no? It should be false. Well, you tell me. Okay, okay. Well, just tell me if you're not sure. Okay, don't guess. Okay, the binomial distribution uses sampling with replacement, and the hypergeometric distribution uses sampling without replacement. Okay? You understand the concept with replacement and without replacement? Yes, okay. Okay, the expected value of a sum of random variables is equal to the sum of the expected values of each random variable. Is this true or false? They're clapping for you. So is that your answer? Yes? I'm sorry. The expected value of the sum of random variables is equal to the sum of the expected values of each. Oh, you're thinking, okay. Is true. Okay. You are correct. So the expected value of x plus y, your random variables, equals the expected value of x plus the expected value of y. Very good. All right. Discrete variables have means that are integer values, true or false? Sorry, did you answer this one? Discrete variables? Oh, it's false. Okay, and why is it false? Why are you saying it's false? Okay, and why can it be a non-integer? That's exactly correct. The mean can be a non-integer, but the value must be an integer, right? Very good. So the values of discrete variables are integers, but the mean can be a non-integer. Excellent. Okay. The probability of the success of a trial or observation for a binomial probability distribution depends on the trial or observation that came before it. Is this true or false? False. And why is that? Think about it. Think about the distribution. It's a binomial distribution. So you have trial one, then trial two. Okay, but does it depend on the previous trial? That's what the question is asking. No, and why not? You got it. I just want you to tell me why you think it's not dependent on the previous one. Right. Because the previous trial is done. So it has no influence on the next trial. Okay? So the probability of success remains constant in a binomial distribution. Exactly. That's what you should think about if you get a question about binomial distributions. So the probability of success remains constant in a binomial distribution and is not influenced by past events. The outcome of flipping a coin does not impact the next flip. The probability of it landing heads remains 0.5. Exactly what you said. Very good. Okay, number 9. A manufacturing process produces defective items 5% of the time. A sample of 20 items is taken for quality control. If you wanted to determine the probability that exactly 2 of the 20 items are defective, which distribution should be used? Binomial, Poisson, continuous, or hypergeometric? You're not sure. Okay. So you feel it's A? Your bones tell you it's A? Okay. You're correct. Instinct, right. Okay, so this is the answer. So because the manufacturing process has a known, okay, that's why you have to look at the words carefully, known 5% defective rate. Each of the items has a 5% chance of being defective regardless of how they are sampled. Does that make sense? Yes, no, yes. Okay, so this condition is equivalent to sampling with replacement or using a binomial distribution, right? So every time you do it, there's always a 5% chance that whatever they're making is defective, okay? Which is the binomial. There's success or there's failure, all right? So, um, 5 out of 100, it's going to be defective. But you got it. I guess your bones were working properly. All right. Number 10, a student randomly guesses on a multiple choice exam that has 15 questions with 4 options for each question. What is the probability that the student gets exactly 7 questions correct? I don't know if you have a calculator. Do you have a calculator with you? Can you try to figure that out? I'll give you like 30 seconds. Okay, try it. Have you got anything, Tony? Okay. What's the fourth digit? Yeah, you are actually correct. Very good. Excellent. Good job. I can't, what is the fourth digit in that calculation? Oh, they're doing a rounding. They're doing, right. Okay, they're doing rounding to 2 decimal places. Okay, but very good. So you use the formula for the binomial distribution. N equals 15, P equals 0.25, and X equals 7. Very good. Excellent. All right. The Poisson distribution is to quantify the probability associated with a certain number of outcomes in which of the following: 1 minus P failures, N trials when sampling is done with replacement, N trials when sampling is done without replacement, or some interval of time. Is that a word? M? Okay, it should be D. And why is that correct? Some interval of time? Why did you select D? Why? So tell me why you selected D, Tony. Okay, but you are correct. But remember, you link interval of time with the Poisson distribution. So the Poisson distribution is used to determine the probability associated with the number of times a particular event occurs throughout an area of opportunity. Example, interval of time. Very good. That's great. Okay. Number 12, the mean of a Poisson distribution is always equal to its variance. True or false? So the answer to this question is true or false. If you're not sure, okay, it's true. And is that a property of the Poisson distribution? That the mean is always equal to the variance? Yes, no? Yes, don't think so. It is so. The mean and variance of a Poisson distribution are equal to lambda, the expected number of events per unit time, volume, or area. Yeah, your memory seems to be working fine. Okay, number 13. A magician asks you to draw 4 cards from a standard 52 card deck of playing cards. The probability that you have exactly 1 ace in your 4 card hand is best described by a binomial distribution in which the probability of success drawing an ace is 4 out of 52. Is that true or is that false? Okay, and why is that false? Exactly. Very good. You're drawing the card without replacement. Excellent. And it should follow the hypergeometric, which is true. So you're drawing the cards without replacement, like you said, so this application must follow a hypergeometric distribution. Very good. Okay. The probability of a student randomly guessing answers to a true-false exam is best modeled with a binomial distribution. True or false? Right, because they're guessing. So remember, in the binomial, the previous event has no effect on the next event. So that's what guessing is. The probability of guessing correctly is always 0.5 and the outcomes are independent. Excellent. All right. Number 15, trains pass an intersection at the rate of 4 per day. What is the probability that exactly 5 trains will pass the intersection tomorrow? If you can use your calculator. I'll give you another minute. Remember what the clues are in determining what distribution you're going to use. So it's, what is the probability that exactly 5 trains will pass the intersection tomorrow? D, correct. Excellent. Excellent. Right. Very good. Because you are applying the Poisson probability. Using lambda is 4 and x equals to 5. Very good, Tony. Excellent. All right. Number 16, the hypergeometric distribution is similar to a binomial distribution, except A, sampling is done with replacement in the hypergeometric. B, the probability of failure is 1 minus p. C, there are more than 2 possible outcomes in the hypergeometric. And D, the number of trials is larger in the hypogeometric. Okay, you got A. That is also correct. Very good. Very good. Whoops. Sampling is done with replacement in the hypergeometric. Right. Right. I'm sorry, it's not done in the hypogeometric. Okay, question 17. The formula for the binomial probability distribution takes into account both the probability of success as well as the probability of failure. True or false? So what do you have for your answer for question 17? True or false? True. Correct. Correct. Very good. The binomial probability distribution uses the probability of success, p, and the probability of failure, 1 minus p. Right. Excellent. Whoop. No. Did we do this question? No. All right. So the probability the probability of success for each occurrence in a hypergeometric distribution depends on the outcome of the previous trial. True or false? You think it's true or you know it's true? Tony? It's the nature without replace. Right, exactly. So it's true. The probability of the success of a trial for a hypergeometric distribution depends on the outcome of prior trials. This is part of the nature of sampling without replacement that distinguishes the hypergeometric distribution from the binomial. That is basically the main factor, the main difference between one is with replacement, one is without replacement. Very good. All right. 19. A case of 15 compact fluorescent light bulbs is known to have 2 that are defective. If a sample of 4 light bulbs is selected, what is the probability that exactly 1 will be defective? So if you can try to figure that one out. Don't mind me. Okay, are you working on that? Give you another minute. Okay. Are you getting close? Okay, which is close to which answer? The D. Very good. Excellent, Tony. Excellent. Stupendous. So you use the formula for the hypergeometric distribution with n equals 15, or sorry, the population 15, the sample 4, a is 2, and x equals to 1. Very good. Okay, number 20. 50 households in a particular neighborhood will file federal income tax returns, and 5 will be fraudulent. That just means they lied on their income tax. If the Federal Revenue Commissioner selects 10 tax returns for detailed auditing, the number of fraudulent returns detected will follow what type of distribution? Hypergeometric, Poisson, binomial, or normal? A, hypergeometric, and your reason for saying A? Remember, it's telling you in the question already what kind of distribution it is. Without replacement. Exactly. Very good. And therefore, it's hypergeometric. Very good. So that's what you got to look for in the questions, the little clues that you have. So there are two outcomes, fraudulent and not fraudulent, with sampling that is being conducted without replacement. Okay. I don't know whether we covered this. The smaller an area of opportunity, the smaller the probability that an event will occur more than once in it. Did we cover that? No idea. Okay. Doesn't sound familiar? I don't think so. All right. All right. Let's just go to the next one. A probability distribution for a discrete variable depicts all possible mutually exclusive events, and the sum of the corresponding probabilities must be equal to 1.0. True or false? So what do you say? Is this true or is this false? Okay, I'll let you think. Think about what it says in the question. Think about the logic. Okay, can you give me an answer? True or false? True. And why do you say true? Okay, correct. All right, very good. So the probability distribution for a discrete random variable is a mutually exclusive listening. So link those, discrete random variable and mutually exclusive of all possible outcomes, where the sum of the probabilities is 1. Very good. All right. Which of the following relationships regarding the expected value and variance of random variables is incorrect? Incorrect. The expected value of x plus y equals the expected value of x plus the expected value of y. The variance of x plus y equals the variance of x plus the variance of y plus two times the covariance of xy. Okay. And S is the variance of x plus y equals the variance of x plus the variance of y. And the expected value of P equals the expected value of x plus 1 minus w times the expected value of y. Okay, I don't think we covered this. No, I don't think we covered this one. Okay. So we won't worry about it, but what I'll do is I will show you the correct one, but I don't think we didn't cover covariance. I know that for sure. Okay, so the correct answer here is C. The variance of x plus y equals the variance of x plus the variance of y. All right, there won't be any questions about that. Don't worry about that. Number 24, formulas for both the binomial distribution and the hypergeometric distribution use the concept of permutations. Okay, that's like how many multiple combinations can the distribution have? And so what it's saying is formulas for both of them use the concept of permutations. Is that true or false? Think about what the distributions do, or how they're used, or how they're measured. So do the formulas use the concept of permutations, true or false? Both binomial and hypergeometric. You think it's false. Okay. That is correct. The binomial and hypergeometric distributions rely on the formula for combinations to describe a set of outcomes in which the order is not important. Okay? That is the important factor. The distribution is already in the formula, so you don't need to figure out all the permutations. And remember, in the binomial, the permutations are, it's always success or failure, period. Okay? And they're independent because they don't depend on previous trials. Very good. All right. The number of people arriving to a movie theater in a 30-minute time period is best modeled using which of the following distributions? Hypergeometric, Poisson, normal, or binomial? Think about the clues in the question. So which distribution would be the better one to apply to this data? Look at this part. They arrive in a 30-minute time period. Okay. It's an interval of time. Right. Okay. So I want you, and I've told other people, or I've told the class, look at the clues within the question. You've got it here, 30-minute time period. You use Poisson. That's correct. There's a 30-minute interval of opportunity for which customers to arrive to the movie theater. There you go. Very good. All right. The number of LCD televisions sold during a day is an example of a continuous random variable. Is this true or false? Think what it's asking. Is this the number of LCD televisions related to this continuous random variable? So is it true or is it false? That's false. And why is it false? What is the relationship between the number of televisions sold and a continuous random variable? You said it's false, so does that mean they're not equivalent? You are correct, Tony. They are discrete. The number of televisions is discrete, so it doesn't matter. It's not continuous. It may be a large number, but the television sales represent a discrete number. Very good. So again, always look at the question and see what the relationships are that are within the question. All right, number 26. If the binomial probability of success is near 0.5, then the distribution is approximately symmetric. True or false? Oh, you said that right away. So let me just make sure. I know. Very good. That is correct. So P at P equals 0.5, the binomial distribution is symmetric and becomes skewed as the probability of success departs from 0.5. Okay, very good. Excellent. All right. So now this one, I want you to be able to, write down what you believe the answer is. Okay, the binomial probability distribution, Poisson probability distribution, and the hypergeometric distributions all look much the same when graphed. Under what conditions would you apply each group of formulas? So you have to name 3 conditions for each of the different distributions. So if you can write down the distribution and beside it the condition, and then I can look at what you wrote. Okay? Thank you. So if you can write that out, and I'll give you a few minutes. Okay. So now you have to give something for the binomial and for the hypergeometric. We've gone through most of them in these questions here, so you know what the answers are. When do you use a binomial probability distribution? What is the condition under which you use that probability distribution? Think about it. And what is the condition under which you use the hypergeometric distribution? Okay, I'll give you 2 more minutes. Okay. So I'm looking at your answers. And basically, yes, they're all correct. Very good. I just have you look at what I had for the answer for the standard answers, but they're basically what you said. The binomial probability distribution is used when the probability of the occurrence of each event is independent of each other, like the coin flipping. The Poisson probability distribution is used when the count of an event is over an area of opportunity, such as a period of time or a physical area, which is what you said. And the hypergeometric distribution is used when the occurrence of an event is dependent on prior events. Exactly. Very good, Tony. And hello, John. Okay. So this question, how does the shape of the binomial probability distribution change as the probability varies from 0 to 1? So what you're looking at is what is the shape and how is it changing as you go from a probability of 0 to 1? So I'll give you 5 minutes to answer the question. So at 11:12. So John, if you can write your answers to this, this is open-ended. This is not true, false, or multiple choice. So in your own words, explain how the shape of the binomial probability distribution changes as the probability varies from 0 to 1. And if you're not sure, then you can tell me. But please try. Okay. So now, Tony, if you can explain what the graph will look like as you're approaching 0 or you're approaching 1. Okay, John, try to figure out what happens to the graph. If you agree with Tony, tell me what happens to the graph as the probability distribution goes from 0. What is it when it's near 0? What does the graph look like when it's near 1? All right, so you've got 2 minutes. Okay, well, Tony, you're saying it's symmetrical when it's 0.5. Have any idea what happens when it's near 0 or it's near 1? Maybe the peak will go to the side when approaching 0 or 1. Okay, do you know where the peak will go, what side it will go to. Okay. All right. And that is actually correct. Okay, so let me show you this. So the shape of the distribution with p equals 0.5 is bell-shaped, which is what you said. That's the middle one. Okay. Well, the shape becomes increasingly skewed to the left as p approaches 0. Okay. This is the right side. This is the left side. It's being skewed. Okay. To the left and to the right as p approaches 1. Here we go. Okay. So you did get it correct, Tony. All right. So you did understand that. Do you understand that, John? All right. So I'm just going to